Hi, today I'm going to go over Unit 4 Pre-Assessment for 5th grade Bridges Math. Problem number 1, it says fill in the boxes to find the product using the standard multiplication algorithm. So this problem means do not use any of your strategies. Instead, try and use the standard algorithm, the standard way that your parents know how to do. So there's a couple steps to that way. First, it's 4 times 7. You multiply the numbers on the right side first, which is 28. They already have the 8 there for you, so you're going to carry the 2. Now that you've finished that one, you're going to do 7 times 5, which is 35, plus your 2. 35 plus 2 is 37, so drop your 7. The 3 is already written for you. Now that that's done, you're done with this side. So you're going to cross out the 7, drop a 0, and you move over one place value until you're right here at the 6, which means 6 times 4 is 24. There's a 4, carry the 2. 6 times, so we're going to carry the 2 again. Sorry, I didn't show you that. Then 6 times 5 is 30 plus 2. So here's my 2, and then I write a 3. So my final answer is 3,000. Whoops, sorry. Can't add from the left side, have to start on the right. So 8 plus 0 is 8. 4 plus 7 is 11. 1, I carry my 1. 2 plus 3 is 5. And 1 more is 6. Then I can drop my 3. So my final answer is 3,618. Problem letter B. Same thing. We're going to start with the ones column. 2 times 7 is 14. Here's my 4. I'm going to carry my 1. 2 times 8 is 16 plus the 1, which is 17. 2 times 3, oops, carry my 1. 2 times 3 is 6 plus the 1, which is 7. So I have 774. Now I can cross off my ones column, and I need to move over to the next column. Now I'm going to multiply everything by the 7. 7 times 7 is 49. I have to drop my 0 first. It's hard to do standard algorithm when you're used to doing all of the fun strategies. So I drop my 0 first. 7 times 7 is 49. So I put my 9 and I carry the 4. So I'm going to change that 1 to a 4. 7 times 8 is 56 plus 4, which is 57, 58, 59, 60. So I drop my 0 and carry my 6. 7 times 3 is 21. 21 plus 6 is 27. So drop a 7 and a 2. So I have 27,090 plus 774. 4 plus 0 is 4. 9 plus 7 is 16, so I'm going to carry my 1. 0 plus 7 plus 1 is 8. Drop my 7, drop my 2. I have 27,864 as my final answer. Number 2, it says use standard multiplication algorithm to find 25 times 448 and show your work. So you're going to do the exact same thing that we did up here, only you'll do all of the steps. So I'm going to do it on a separate sheet of paper, just in case I need more room. So I have 448 times 25. Okay, it's always easiest to put the biggest number on top, and remember with multiplication, it doesn't matter which one you have in the front or in the back. So I have 448 times 25. So 5 times 8 is 40. Drop my 0, carry my 4. 5 times 4 is 20 plus 4. Drop the 4, carry my 2. 5 times 4 is 20 again plus 2. So I have 22. Now I can cross off that 5 and drop a 0 to hold the place and move over 1. So 2 times 8 is 16. Here's a 6. I'm going to change that to a 1. 2 times 4 is 8, plus 1 is 9. 2 times 4 again is 8. And I didn't have to carry anything, so that's from my last one. So 2 times 4 is just 8. Now I can add those two numbers together. And I have 0, 0, carry my 1. 1 plus 2 is 3, plus 9 is 12. 1 plus 2 is 3, plus 8 is 11. So my final answer is 11,200. Okay, and if I wanted to double check my work, I could always use one of my... Moving on to problem number 3. 3/4 of 48 is, so 75 times 48 equals. So as you can see, the answer is 36 and 3,600. I'm going to show you how we got that. 1 times 48 is 48. Okay, half of 48 is 24. Half of a half is 1/4. So 1/4 of 48 would be half of 24, which is 12. Well, now if I add these two numbers together, because 1/2 and 1/4 is the same thing as 3/4, I take these two numbers and add them together, and I would get 36. Well, we all know that 3/4 is the same thing as 0.75 or 75 hundredths. Okay, so now looking at the next one, it says 75 times 48. Well, 3/4 of 48 we discovered is 36. And we know 3/4 is 0.75 or 75 hundredths. If I have 75 instead of 75 hundredths, all I'm doing is multiplying this by 2 place values or multiplying it by 100. So 0.75 times 100 is the same thing as 75. So 36 times 100 would be 3,600. Okay, same thing looking at number 4. I'm just going to fold my paper in half so we don't get confused with all these numbers. Fold it down. We'll start the next problem. So I have 1/4 of 64 is 16, and 25 times 64 is 1,600. Well, 1 times 64 is 64. Half of 64 is 32. And a half of a half is 1/4, as we all know. So 1/4 would be half of 32, which is 16. So now we know that 1/4 of 64 equals 16, which is the same thing as 16 times 0.25, or sorry, same thing as 64. Mrs. Hanley made a mistake. Same thing as 64 times 0.25 equals 16, because 1/4 and 0.25 are the same amount. Okay, so now, as we did before, 64 times 0.25 equals 16. But we need 25, not 0.25. So in order to get 25, I have to take 25 hundredths and times it by 100 to move it over 2 place values. And I get 25 wholes, right? So if I then take 16 and move it over 2 place values, I have 1,600. Because 25 times 64 would be 1,600, because it is, instead of 0.25, it is 25, which means it's 1,600, because we now multiply it times 100 and times 100. Whatever we do to the bottom, we have to do to the top. Okay, for the next set, it asks you to figure out if the problem is true or false. Mark each of the equations below true or false. If you use your estimation and mental math skills, you may be able to get the correct answer to some of these without doing all the computation involved. So looking at the first one, it is true, but let me show you how we get that answer. We have 32 times 4 equals 1,280 divided by 10. Okay, so 32 times 4, I can break that up. I can do it several different ways. 1 times 32 is 32. 2 times 32 is 64. If I double that again, I would have 4. And if I double 64, I'd have 128. So if I have 128, well, what is 10? 10 would be 1,280. So is it the same? 10 and 1,280, 32 times 4, 128 and 1280. Yes, they are equivalent. It is true. Okay, the next number or letter is B. So I'll move down to B here. Let's see if I can. Okay, so on B, I have 342 times 28 equals 3,828 divided by 3. Okay, looking at this problem here, before we even do any math whatsoever, I know that if I have 342 times 20, or even let's round to 30, 342 times 30. Well, 342 times 3 is 3 times 3 is 9, 3 times 4 is 12, and 3 times 2 is 6. So I'm going to have somewhere in the, and then I add another place value, I'm going to have somewhere in the 9,000s. Okay, just by looking at this number, 3 times 342 is 900 and something, at least, maybe even 1,000. So, but now I have it 30, so it's going to be a very large number. Looking here, 3,828 divided by 3, that's going to be a much smaller number. When I divide something, I make it much smaller, so there's no way this is going to be more like 1,000. Just so you can see, so it makes a little bit more sense. If we actually do the standard algorithm, 342 times 28, 8 times 2 is 16, 8 times 4 is 32, plus 1 is 33, 8 times 3 is 24, plus 3 is 27. I'm going to cross that off, drop my 0 to move over one place value. 2 times 2 is 4. 2 times 4 is 8. 2 times 3 is 6. 6, 7, 15, and 9. 9,576. So as you can see, my number is quite large, my 9,576. And this down up here, it's going to be much smaller than 9,576. This is going to be somewhere in the thousands, because 3 into 3,000 is going to be 1,000. 3 into 8 is not quite 3, but somewhere around there. So it's going to be around 1,200-ish. And this is 9,576. There's no way that those two are going to be equal. So the answer is false. On C, the easiest way to do this one is the overage strategy. And you can even do it in your head. So let's round 558 times 99. The closest thing it's to is 58 times 100, which gives me 5,800. 5,800, is that anywhere close to 4,897? It's almost 1,000 off, so the answer is false. On the last one that we have, D, it is true. We have 480 times 25 equals 12,000. You could do standard algorithm, you could break it up to do the break apart strategy, you could make a ratio table, but 480 times 25 does equal 12,000.